Cassini's observations of Saturn provide new clues about its rings. NASA's Cassini spacecraft has explored Saturn's family of icy moons and signature rings for nearly 2 decades. The Southwest Research Institute has compiled 41 observations of Saturn's rings during solar occultation using Cassini data. Saturn's rings formation and evolution will be better understood through a compilation published in the science journal Icarus recently. NASA's Cassini spacecraft has explored Saturn's family of icy moons and signature rings for nearly 2 decades. However, we are still unclear about the origins of the ring system, said SWRI researcher Stephanie Jarmak. According to evidence, the rings are relatively young and may have formed as a result of debris thrown off by icy satellites or comets. However, for scientists to prove any one origin theory, they need to clearly determine the size of particles that make up the rings. Cassini's ultraviolet imaging spectrograph, UVIS, was uniquely sensitive to ring particles down to the smallest sizes. This is thanks to its observations in the extreme ultraviolet wavelengths. During what is known as solar occultation, UVIS looked through the rings to measure the size of the ring particles. In order to determine the size and composition of the ring particles, the optical depth was determined. This was done by partially blocking the path of the light. These observations provided insight into Saturn's ring's smallest particle sizes. This was mostly thanks to the wavelength of light coming from the Sun, according to Jarmak. UVIS had the capability of detecting dust particles at the micron level. As a result, scientists can understand how ring particles are formed and interact with each other. However, they are crucial in understanding how they are destroyed within the system. As part of the compilation, the optical depth of occultation observations is also examined, which may be useful for predicting particle size and composition. During occultation, particles in the light's path absorb and scatter light emanating from the background source. By measuring the amount of light blocked by ring particles, we can determine the optical depth of the ring. Understanding the structure of the rings requires an understanding of optical depth. Researchers measured optical depth according to the viewing geometry, which is the view angle of the Cassini spacecraft relative to the ring system. By observing how light passes through the rings at different angles, scientists can determine the ring structures. In addition to providing test beds for fundamental properties and processes in our solar system, ring systems around giant planets are also good places to study fundamental physical phenomena. Scientists believe these particles are formed through collisions in disks and build up into bigger particles. The formation of these ring systems may also provide us with insight into how planets form. The paper Solar Occultation Observations of Saturn's Rings with Cassini UVIS appears in Icarus.